A2 Maths modulus function. So we've seen this a few times. It's popped up. We haven't really done much work on it. And it's what's called the modulus function. Now the modulus function is something that finds the size of a number, the magnitude of that number. It's what's called a scalar quantity. In other words, it has no direction. That's important when you consider what it does to negatives. Now the modulus function, as we've seen before, is written as this sort of symbol. It's denoted with two straight lines either side of it, and it means what is the modulus of x. That's how you write it. So you've seen this thing before, and the example I would say is when you were doing binomial expansion recently, and we've seen it being the modulus of x is less than or equal to 1. So we've seen this thing come up, but we haven't really done a huge amount of work on it. So what we're going to look at now is what it means to just numbers. So what is the magnitude of 5? What is the modulus of the number 5? So if you imagine you started at 0 and you walked to the number 5, then you would have travelled a distance of 5. It does not change that number at all. Okay. Whereas if you looked at the modulus of -6, in other words, if you started at 0 and you walked back to -6, the distance you would have travelled is still going to be 6. It doesn't care about direction. It doesn't care that you walked back to get to -6. It just cares about the fact that you've travelled 6. So that's what the modulus function does. It changes anything negative into positive. Okay, and anything positive, it does not change it at all. Okay, so anything positive stays the same. Anything negative changes it to positive. Right. So what I'd like you to do, just start on a piece of paper on your little whiteboards. Just have a go at plotting y equals 2x plus 1. Just pause it until you've got that drawn down. Okay, so hopefully you managed to plot a straight line, gradient 2, crosses at 1. Doesn't need to be a work of art, but that's what you've got. Okay, now what I'd like you to think about is what does y equals modulus 2x plus 1 look like? Okay, so you might want to just pause and have a go yourself, or you might want to just listen to the answer. Okay, so because it's the modulus of 2x plus 1, well, anything that's positive, so any of these values here, they came out as y is a positive number. Y equals 1, y equals 2, y equals 3, and so on. So those y values came out as a positive number. So these bits wouldn't change with the modulus. The modulus of those will be exactly the same. But anything negative, anything on that side, will change. So this number here came out, let's say, as -1, but what the modulus function does is it takes that -1 and it changes it to 1. What about here? Oh, this came out as -5. Well, -5, when you take the modulus of it, what's the magnitude of -5? It becomes 5, so it's going to be up here. So what happens is all of those numbers that are there are actually going to be transformed to positive numbers. So anything that was negative becomes positive. And that is the graph of y equals mod 5x plus 1. Anything positive was exactly the same as 2x plus 1. Anything negative got reflected up to that part to make it positive. So what I'd like you to do is just have a quick go at those 5, remembering those key facts that anything under the y equals 0 line, anything underneath that is going to be made positive. So therefore it's going to reflect up. Just have a go at those 5 questions. So pause, have a go, then replay and have a look for the answers. Okay, so let's see how you got on. So 3x minus 2, that's similar to the previous one. There's 3x minus 2, going all the way down like that. What does a modulus function do? It reflects it up. Missing an x out there, so it should reflect it up. Okay. What about x squared minus 3? So there's x squared minus 3. Notice that x squared minus 3 went down here to minus 3 and went back up. That's what the graph looks like. So what does the modulus do? Anything positive stays the same. So those two sections stayed the same. But this section that was got negative answers, that got reflected up. And so you end up with this sort of W symbol like that. What about a cubic? Okay, so think about what the cubic function looks like. Looks like this. There we go. Anything that's positive stayed the same. Anything negative, like there and here, got reflected up. So you end up with this sort of bouncing pattern like that. Okay. What about the cos function? So cos sort of usually does this wave function like this. So it does the same wave function, but any part that went negative, like that, goes up to this value. So again, we've got this sort of bouncing pattern for the magnitude of cos. Same with tan. Think about your tan graph. You should know tan graph off by heart. It comes up, it does that, it approaches an asymptote, it starts repeating. So what happens is anything negative is going to be positive. So this negative here will come up. So you're coming down, and it's got like a set of sharp points there, 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 and so on. And those patterns are going to keep repeating over and over again. Okay, so hopefully that makes it a little bit more understandable that if you have a modulus function, anything that is below the line y equals x just reflects up to the positive side. Okay, so let's try something a little bit different. What I'd like to think about is, what does that look like? Y equals 2 mod x minus 1. Okay, so you might want to pause, you might want to play with that and think, see what you get. Okay, so my starting position would be, think about what the graph of mod x looks like. So there's y equals mod x. And let's just do one bit at a time. What does the 2 do? Okay, so what would you say 2 lots of mod x would look like? Well, we know that multiplying by 2, it's not inside the modulus function, so it's outside the function. So multiplying by 2 is exactly the same as a stretch scale factor 2 in the y-axis. So really, this graph here should look like that. Okay, so y equals 2x, or 2 mod x, looks like that, which makes sense because there's y equals 2x. All right, keeps going down. It's slightly steeper gradient than y equals x. What does minus 1 do then? So think about what minus 1 does to functions. What if you had x squared minus 1? What if you had sine x minus 1? What does minus 1 do? Well, it takes your function and it translates it by 0 minus 1. So it translates it by the vector 0 minus 1. So that entire graph will just drop down to minus 1. And there we go. That's what the graph of 2 mod x minus 1 looks like. Notice, because the modulus function is not around the whole thing, there is parts that fall down here. Okay, so there is parts that come down underneath. Any function of the form f mod x is a reflection of the positive x values of f of x in the y-axis. Right, so I think what that's saying to you. Any function like that that has the modulus function around the x is always a reflection in that y-axis. So you can see that there like that. It doesn't matter what all these other bits and bobs do. If you've got mod x like that, it's always going to be a reflection in that y-axis. That's what that says. Okay, any function where the mod is just around the x, always a reflection there. That wasn't true for the previous ones. We saw that sort of bounce in here, for example. Okay, that's different. Okay, so what I'd like to do, just have a go at the exercise 6.1 on 249. So that's just practicing a bit more about drawing the graphs, understanding your modulus functions, those sorts of things. Okay, right. So let's have a look at solving some of these mod equations. So we've just drawn that previously before you did the exercise. 2x minus 1 equals 13. And when we drew it, when we actually drew that graph, we could see from that previous graph, there it is, that if I plot 13, then I can see that I'm going to have 2 possible answers. One here, one here. So the blue line is the 2x minus 1. That line is 13. The question is, how do I get these 2 possible answers out? And the way we get the 2 possible answers out is by understanding that the modulus of some sort of function, it doesn't matter what it is, in this case it's just a simple x value, the modulus of some sort of function can be rewritten with plus and minus at the front. So a function like that, it could be a positive value, because then the modulus functions don't change it, or it could be minus f of x, in which case the modulus functions do change it into the positive value. So let's have a look how we actually work this out then. So we want 2 mod x minus 1 equals 13, but it can be two different possible solutions then. The first solution is if x is positive. Okay, so let's just have a think. If x is positive, then the modulus functions don't do anything different. They leave it alone. In which case you get 2x minus 1 equals 13. So x will equal 7. That is that possible solution just there when we had positive x. The other solution we get though is if that mod x value was negative. Okay, now if that mod x value was negative, what I end up with is 2 lots of minus x minus 1 equals 13. In which case x is going to equal minus 7. I just check it. You put minus 7 back into here. Minus 7 modulus is going to be positive 7 times by 2 is 14. 14 take away 1 equals 13. So x equals minus 7 is that second solution just there. So you can still solve mod functions by just changing that mod part into a positive and negative to check out the solutions. Okay, let's try it with this one. What about if I had mod of 2x minus 1 equals 13? So a really subtle difference there. Now the modulus doesn't just go around the x, it goes around the whole thing. Okay, same idea as before. Let's just have a quick think about the graph. Okay, so there's the difference in the graph. Look, it's very subtly different. Last time it went down here and bounced up there because it was a reflection in the line y, the y-axis. Now it's moved across, so there we go. And a 13 is there. So what difference does it make? So we do the positive solution first. And in fact, because we've got the positive solution, that's exactly the same as last time. X equals 7. We can see that, no different. The negative solution, though, means that we take the negative version of all this. So we take the negative version of all of that. We're going to get minus 2x plus 1 equals 13. Or I can take the minus over the other side, which I've done there. Okay, to make minus 13. It's the same answer. Then what? Add 1, divide by 2. So we can see we get minus 6. Does that work? 2 lots of minus 6, minus 12, minus 1, minus 13. The modulus of that, 13. Okay, so it doesn't matter where those modulus functions are as long as you separate it to plus and minus. It also doesn't matter which side you pick as well. So if you wanted to just choose that side, you can make 2x minus 3 equal plus 13 and 2x minus 1 equal minus 13. That would work just as well in this case. There's nothing wrong with you picking either side to make plus and minus. Okay, so here's one to practice on your own. Just have a go at solving this mod function using the skills I just showed you and see how you get on. Okay, so you might want to pause, re-listen to my answer, see what you get. Okay, so let's have a look. So you started off with mod 3x plus 2 equals 2x minus 3. You decided that you want to take the positive answer. Great. So there we go. 3x plus 2 equals 2x minus 3. And we end up with x equals minus 5. Nice and easy. And then you take the minus answer. Okay, a little bit more work on that. So minus 3x minus 2 equals 2x minus 3. You expand that out, you simplify it, and you've got x equals a fifth. What I'd like you to do is just check those answers in the original equation. So just have a check and see what you notice. Okay, so if I put these values back into this original equation, something a bit strange happens. If I put minus 5 into here, I'm going to get 3 times minus 5 is minus 15. Minus 15 plus 2 is minus 13. The modulus functions make it plus 13. So this side is clearly a positive answer. It has to be because of the modulus. But on this side, I'm going to get 2 times minus 5 is minus 10. Minus 3 is minus 13. And that's just not right. This side was positive 13. This side was negative 13. And the same sort of thing happens when you put a fifth in there. 2 times a fifth minus 3 is going to be negative. How can that be the case when this side is modulus? So although the algebra is sound, you haven't done anything wrong with your algebra just here. Okay, so your algebra is absolutely spot on. The problem comes with the fact that you need a bit more work when it comes to modulus. So what I'd like you to do is just have a go at sketching this graph. Well done if you've done it already. You've probably already spotted what the problem is. But if you didn't, have a go at plotting it. So can you plot y equals mod 3x plus 2, and on the same graph, y equals 2x minus 3, and see what happens. Okay, so you want to pause, have a go at plotting both of those. Okay, so let's see what you got on your plot. So if you plotted the modulus of 3x plus 2, that is what you should have got. Y equals 3x plus 2. There's your modulus function there. If you plot 2x minus 3, that's going to be a straight line with a gradient of 2 that crosses at minus 3. But what's important about it is it's got a less of a gradient than this bit. So they're never going to cross. This is going away, this is going here. They're never going to cross. So I can see that actually, if I'm looking to solve this, I'm saying when is that graph equal to that graph, there isn't going to be any solutions. This blue line here bounces off, goes up here, goes up here. It never ever crosses that red line. It's never going to cross it. So this bit here has no solutions. Okay, so what was the algebra doing then? Well, what the algebra does is it actually doesn't just work out where this modulus function hits. Because you're solving two equations, you're actually solving two lines. This line that keeps on going all the way down here, and this line that keeps on going all the way down here. And if you carry these lines on going, they will cross. For example, this line here will cross about there at a fifth. This line and this line, they will cross in the end right down here somewhere at minus 5. So they will cross, but on their bottom parts of their lines, which is the bits you don't want. So the point of this exercise is to make it very clear to you that solving modulus functions with the algebra alone isn't going to help. You should always think about the sketch. You should definitely always check your answers just in case the examiners try and trick you out. Sometimes you get equations where there's only one solution, sometimes you get ones with no solutions, and it's worth making sure you check the graph. Okay, so yep, it's got no solutions. Always sketch when trying to solve modulus equations. Just even a quick rough sketch to make sure you know how many solutions there are. Okay, so solve that. You might want to do exactly what the previous slide said. Do a quick sketch, see how many solutions you get, and think about how you go about solving it. Okay, because if you're going to solve it, the problem is because you've got two modulus functions, which ones do you make positive and which ones do you make negative? And you would be right in thinking, isn't there 4 possible ways of doing it? This one's positive, this one's positive. This one's positive, this one's negative. This one's negative and this one's positive, and this one's negative and this one's negative. So there's 4 different options, both positive, this one negative and that one positive, that one positive but that one negative, and both negative. So what I'd like to do is just investigate those following, just in other words, work them out, see what you get. Okay. Right, so let's see what you found out. So you've solved that one, x equals 3. Solve that one, x equals 1. Solve that one, x equals 1. Solve that one, x equals 3. So there's 4 different ways of doing it, but actually they all boil down to just 2 equations. So this is going to help us when we come to solving a modulus equals a modulus. You don't need to do 4 equations. You just need to do 2 equations. The question is, which 2 do you do? So when you come to solving it, what you look at doing, yep, there's a graph. And where's the modulus one? There we go. And there's our 2 solutions. So we're definitely right. We've got 2 solutions. Nothing tricky about it like there was before. This is your number 1. This is your number 3. What it's saying is that when you come to solving it, just pick either of the 2 sides. It doesn't matter which ones you pick to be your positive and negative. So in this case, you might just say, look, the x is on its own. That's going to be the easiest option. So my positive solution, I keep them both positive. and therefore I get this. But my negative solution, I leave one of them alone and just change the other side. And that's why this negative idea, people fall into the trap of making them both negative, and then you get a repeated answer. So when you choose a negative, ignore the fact that you have two modulus functions, just leave one alone and change the other one to a negative. It doesn't matter which side you choose. There's your example there. You'll always get x equals 1. Okay. All right, so you got the graph in front of you. Let's say you've done the previous work. That's what we just did a minute ago. We found our solution of 1 and 3. We solved that. How would you solve an inequality when it comes to modulus functions? So you might want to think about it yourself. Okay, if you've got the graph in front of you, if you've actually drawn it all out, the answer is very similar to any other inequalities you've drawn. If you think back to x squared, for example, if you've got a straight line and a quadratic, it's exactly the same sort of concept as that. You're trying to think, when is this graph just here bigger than this graph just here? So at certain points, it's definitely bigger than it. Look here, for example, this x value here, which let's say is -2. At -2, the mod x graph is down here at quite a small value, whereas the mod 2x plus 3, 2x minus 3, excuse me, has a higher y value. That is definitely bigger, greater than that graph at that point. Okay, and in fact, it's bigger than it here. It's bigger than it. It's definitely bigger at 0 because mod x is 0, and this one here comes out to be 3. So it's definitely bigger there. It doesn't change over till you get to number 1, and when you get to number 1, they swap places. Now this graph is smaller than this graph. It's less than it here. It's less than it here. It's less than it here. It's less than it all the way up to number 3. Then once you get to number 3, now this graph takes over again. And this graph is the greater one. So we look at when it's greater, like I just showed you, definitely here from number 1 downwards. That red line there is definitely above the green line. What about the other parts? Well, when it's less than 1, but also when you get to number 3, it's definitely bigger than it there. So that part there, when x is greater than 3, is the other part where this line is above it. So that would be your solution. If it was the other way around, when is it less than 3, you would have it between 1 and 3. If it was less than or equal to, these will be filled in, and this will be less than or equal to and greater than or equal to. So just be careful with inequalities. But the point is, it's exactly the same as any other graphs you've drawn. My advice to you is always do a quick sketch so you don't make any silly mistakes. Set notation, we've seen set notation before. The examiner is going to use this set notation at certain times, so you need to be aware of it. So let me just run through it again, what it means. That's your variable x. So it's saying when I've got the variable x is less than 1, or when I've got the variable x is greater than 3. So using that sort of symbol for or, it's that one or that one, and you've got these extra brackets to just show those two parts separated out. They don't expect you to write it like that, but they would expect you to understand it if you see it like that. Right, so there's 2 exercises on the modulus function. So I'd like to have a go at both of those, solving it, but do not be lazy. Make sure you sketch those modulus functions.